Um, Page 6, which is the last page of normal distribution. We're only going to do some of these because a lot of them are things that you're already comfortable with from doing so many problems on the previous 5 pages. So for example, for 7, I'm only going to do part C, okay, because you're not so used to doing the inverse normal operation. So I'm just going to do that one. First step, even though they don't tell you to draw it, I want you to draw it, okay? So the mean is 8,000. Oops, that's too many zeros. And then the standard deviation is 1,800. So that means that the first standard deviation line is not 8,000 plus 1,800, which is 9,800. And the left standard deviation line would be 8,000 minus 1,800, which would be 6,200, something like that. Okay? All right, so we've drawn our picture. So it is known that 12% of the television sets break down before T hours. Only 12%. Okay, so 12% is actually a very small area. It would just be, now it's 12% before T hours, so that would be less than T hours. So that would be like a little region over here, right? Because we're talking about a region that is less than a certain amount, which happens to be named T, okay? So less than T hours, there's 12% here. Okay, so there's 12% less than T hours, it's 0.12. Um, okay, so now, how do we get the calculator to tell us what T is? We know that the region is 12% in terms of area. Where is this T located? Well, the calculator only needs 3 things to figure that out. It needs 0.12, which is the area of the left region, and then it needs 8,000, and it needs the standard deviation of 1,800. So let's do that. We'll do second dist, and we'll do inverse normal, and then we'll give it 0.12. Remember, you cannot give it 12, a whole number 12, because anything bigger than 1 and the calculator gave you an error. People do that on the test because they forget what they're supposed to do, and then they're just like, they have no idea why the calculator is giving them an error. And I cannot answer that question on the test. Sorry. 1,800. All right, so 1,800 is sigma, that's why I put it there. And then the paste, and it tells me 5,885. Let's see if that makes sense. We mark T over here to the left of 6,200, and look, that's a pretty good estimate. The answer is 5,885, and that's kind of around what we would expect, right? So do you see why it's good to draw the picture? When you plug back in the number, you can kind of confirm that it's the right number because to see if it kind of fits in scale, and it does. So yeah, C, that's the answer for C. Okay, moving on to number 8. The speed of cars on a motorway is normally distributed with a mean of 120 kilometers per hour, and this is kind of a weird notation. You know, we don't usually see this too much in math. Um, That's all it means, right? Hours to the -1. Power is just hours in the denominator. Sometimes they use that in physics, but not too much either. I think they were just too lazy to, write it like that. And the standard deviation is that, okay? So this is sigma, and this is mu, the mean. Draw a normal distribution diagram to illustrate this information. Ah, a man after my own heart. They ask you to draw it. I think you should always draw it, even if they don't ask you. But it's nice when they ask you because then you draw it and you actually get a point for it, okay? So it kind of looks like that, right? Separated by units of 10. All right, so we did A. Now C. It is known that 8% of the cars are traveling at a speed of less than p kilometers per hour. Find the length, find the value of p. Okay, so we know that 8% of the cars are less than p kilometers an hour. And so that would be like a region kind of over here, right? 8%, a small region, right? It wouldn't be over here because this would be like greater than P, and we don't want greater than P, we want less than P. Okay, so we know that's 8%, also known as 0.08. And we know that the mean is 120, and we know that the sigma is 10. And now if we put these three numbers in the calculator, it can tell us what this value is, which here they call it P. So what is P? Well, the calculator can tell us. Second dist, inverse normal. We're going to put in that the area is 0.08. We're going to put that the mean is 120 kilometers an hour. And we're going to put that the standard deviation is 10. And then we're going to paste and run it. And we get 105.94 blah blah blah, which is 106.0, right? Okay, so we're going to say it's 106. And look, our picture is pretty good. We estimated that it would be a little bit to the left of 110, and what do you know, 106 is a little bit to the left of 110. So that's fine for C. Okay? Now what about D? Calculate the expected number of cars that would be traveling at speeds between 96 and 134. Okay, so between 96 and 134. Now this is just a regular problem, except, you know, maybe you're not really comfortable with finding expected number yet, so we'll do this problem for you here. So the mean is 120. The standard deviation lines are separated by 10, right? And let's see, they're asking for some weird numbers. So they're asking for between 96 and 134. I wrote that really messy. Let me rewrite that. So this standard deviation line is 110. Then there's another one at 100. There's one here at 140. And they want to know about the cars that are found between 96 and 134. And 96 would be about here, right? And 134 would be about here, right? So unfortunately, they're not on standard deviation lines, so we do need to use a calculator, or maybe thank God we need to use a calculator. So we want this region. Okay, that's a pretty big region. I would say that's like 80% or something, wouldn't you? So we would use second dist, and we would go to normal CDF. That's what we usually use, right? And then we're going to put in that the lower boundary is the left boundary, which is 96. The upper boundary is the right boundary, which is 134. Okay, we don't need to put infinity, which is kind of a pain to type. The mu is 120, right? Because it's the mean, which is in the middle. The sigma is 100. It's 10, right? Because the lines are separated by tens. Okay. And it gives us 91.1%. We estimated about 80, so that's pretty close. Okay, so 91.1% is the amount of cars, but they don't want the percent. They want the expected number of cars. Okay, well, how do we find the expected number of cars? We don't know how many cars there are. Oh, yeah, we do. 800 cars total. Okay, so the whole region has 800. How many are in the colored region? Well, most of them. 91.1% of them to be exact. So you take 800 and you multiply times 0.911. You don't multiply times 91.1, you're going to get a huge number. You're going to multiply by 0.911 because 91.1% means that it's 91.1 divided by 100. 800 times 0.911. Enter. 728.8. 728.8. Okay? So that is the total, that is the number of cars that drive between 96 and 134. Okay? Moving on to number 9. The weight of bags of rice are normally distributed with a mean of 1,003 grams, which is about 1 kilogram, and a standard deviation of 2 grams. These people don't eat very much rice. When I buy rice, I buy 5 kilograms of rice every time. The weight of bags of rice are normally distributed with a mean of 1,003. So I'm going to put 1,003 here in the middle. Standard deviation of 2 means that each one of these lines is separated by 2. So this is 1,005, and this is 1,001. Okay. Draw a normal distribution diagram to illustrate this information. I just did. Okay, I go on to the last one. Find the value of P when 5% of the bags of rice weigh more than P grams. 5% more than P. So some lucky people are going to get the heaviest bags of rice because they can't make all the bags of rice weigh the exact same amount, right? Okay, so more than P, there is 5%. Okay. Now, again, remember this is a tricky one because what the calculator wants to know to figure out P, it wants to know a couple things. It wants to know the mean. It wants to know the standard deviation. And last of all, it wants to know the left region, not the right region. And we know the right region. But it's not too hard to figure out the left region from the right region. If we know the right region is 5%, the left region is 95%, also known as 0.95. So we're going to put in the area 0.95 into the calculator along with 1003 and 2. And of course we're going to use the inverse normal function. So we're going to put in the area 0.95. We did a problem with 0.95 before. 1003. Standard deviation of 2. And paste. And we get 1006. Okay? So P is equal to 1006. Okay? And that's answering part E. Last problem. Okay. Again, here they do not ask us to draw a picture, but please draw a picture. 3.8 kilograms is the mean. Standard deviation is 0.5 kilograms. Remember that there's a couple problems where like they give you the mean as 3.8 kilograms, but then when they give you the standard deviation, they say 500 grams, and then you add 500, and it just really screws up your drawing. And then after a while, you realize that you made a horrible mistake. You assume that all the units were the same, and they're not. So 3.8 plus 0.5 is 4.3. Is that right? Yeah. So this one's 4.3. This one's 3.8 minus 0.5, which is 3.3. Okay, all kilograms. All right, that's our drawing. It was found that 10% of the babies weighed less than W. Find the value of W. So where's W? Is it like over here, or is it like over here? Well, it's 10% less than that. So it would be very small. It would be like a region kind of like that. Okay, so let's say it's right there. Let's say that that's W. Okay. All right. So what region is this again? How big is it? It's 10%. And how lucky we are. It's on the left. It's the left region, not the right region. If we already know the left region, that's exactly what the calculator wants. The calculator wants the left region, 10%, also known as 0.1, 0.10, if that makes it easier for you to think about it. The mean of 3.8 is another thing it wants, and the other is the standard deviation of 0.5. We're going to do inverse normal. I think you're getting pretty comfortable with inverse normal now too, right? The only tricky thing is when you have a right region instead of a left region. The region is 0.1. The mu is 3.8, and the sigma is 0.5. In the old days, we used to look up these numbers in a table. 3.16. So the weight is equal to 3.16. I mean, the calculator is much easier than looking it up in the table. So 3.16 kilograms is the weight that 10% of the babies are less than. Okay? All right, if they're talking about newborn babies, I think that's ridiculous unless they're talking about like some maybe in America or something. But you know, in Brazil, I think less than 2.5 is premature, and a lot of babies are like 2.5. So, okay, all right, and that is it.